We'll go into a Statkey tutorial now where we look at how to generate a scatter plot and what some of the questions we could be expected to answer about a scatter plot might be. To get started, we will want to select under Descriptive Statistics and Graphs in Statkey two quantitative variables. This is where we go anytime we want to look at a scatter plot. And we're going to upload the file Hollywood Movies. So you may first have to download that file onto your hard drive. We're going to select the explanatory and response variables that we already identified, which were budget as our explanatory variable and world gross as our response variable. So in Blackboard, I'm going to go to Datasets. This is a lock dataset. This is from the Lockbook, so I'll double click on this top item here, Datasets from Lockbook. And it's called Hollywood Movies. This looks like it's sorted. Okay, now I have it sorted A to Z, so I can scroll down until I get to the H's. Here's my Hollywood Movies, and I right-click and select Download. Now that that is saved on my hard drive, I can go ahead and go over to Statkey, and here in Statkey I'm going to select under Descriptive Statistics and Graphs two quantitative variables, then Upload File, and I'm going to search for it on my hard drive, which might not be what it would look like for you, but Hollywood Movies. Now I will choose my explanatory variable first, which is budget. And I will choose my response variable second, which is world gross. Clicking OK gets me the same scatter plot we were just looking at. The first thing I'm going to do is identify the most obvious outlier, which is this one way up here. 237, 2781.5 are the values. I'm going to write those down. Remember that these are measured in millions of dollars, so that's a $237 million budget and about a $2.78 billion gross income. So a very successful movie. We're going to find this movie in the data set by opening it in the Google Viewer. Remember that to do this you want to double click on that data set. Starting again in Blackboard Datasets, double click on the dataset and that will open it in the Google Viewer. So we either come back to Blackboard and choose Datasets, or if you already have it open in another tab, you can come to the Datasets. And now I'm going to just double click on this title and I can see the file pop up. I want to find that budget of 237, and this is a fairly long list, right? If I start, well, it's not all loading quickly. If I start scrolling down, it's going to be hard for me to find that in an unsorted list. So I'm going to go for the 2781.5, which is probably a little bit more unusual, and do just Control F on my computer. Control F brings up this search, and now I can enter 2781.5 and hit enter, and it will highlight it. Now all I need to do is scroll up to make sure that's the correct column. That's world gross. That's good. And now I will see that that's on line 241, so I can scroll left and see that the movie is Avatar. So Avatar is the movie that was this extreme outlier. And it was a very successful movie. Even though it cost a lot to make, it's way more of an outlier on gross income than it is on budget. There were lots of movies that were in the 200s of millions in budget, right? If we look back again at that graph here in Statkey, there are lots of movies that cost over $200 million to make, but this one really stands out by its gross income, the world gross value. So it was a very successful movie because that world gross is what makes it an outlier. Next, we'll look for a point on the graph representing a movie that lost money. So we know that what we're looking for is a value of budget that's higher than the value of world gross. And there are lots that you might pick. Very often people gravitate towards this one because it does look like a relative low here. But you could probably find plenty more coming over to this cluster and just trying to stay on the low end of it. So lots and lots of options of what you could use here. I'm going to choose this one, 150, 38.99. And I think the 38.99 is what I'm going to look up in the data set because it looks a little more unusual. I might get a lot of search results for that 150. Oh, whoops, wrong data set. Okay. So searching again, 38.99. And here I have it under world gross. I verified it's in the right place. I'm going to just search for it again. It's on line 575. As I scroll over, I can see this is the movie Mars Needs Moms. I'm not familiar with that movie, but I think that's kind of the point, right? If it was a flop, I think the whole issue is that it cost a fair amount to make and very few people actually saw it. So Disney feature here about moms and Mars. So Disney's kind of famous for stereotyping. Looks like they found a fairly untapped stereotype to try. The movie with the largest budget. Right, now we're just trying to go extreme on one of the two variables, and we want to estimate or find the gross income for that movie and then estimate the percentile even. So putting lots of things together. Largest budget is going to be the largest value of the explanatory variable. So just the furthest to the right, and it doesn't matter how high up or down it is. We're at 300 for budget and 963.42 for gross income. Looks like that movie is on row 5, and it is Pirates of the Caribbean. The gross income was this value here, $963.42 million. A pretty successful movie. Not as successful as Avatar, but very few have been, or actually none, according to this graph that we're looking at. And to estimate the percentile, that's going to be a little bit tricky. Let's come back over to this graph. The percentile in world gross, what we're really interested in is how many dots are above this one, not paying any attention at all to whether they are to the left or the right. But we can see the line at 1,000 for world gross right above this. We want to count the dots that are above that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like about 12, and we're not going for super precise here. So there's about 12 dots above it, and the number of dots in this graph is 897. So if we put that together, we get that 12 out of 897 are above, and on a calculator, that percent that are above looks like about 1.34%, 0.0134. So there's 1.3% above. Well, that means that this is about, we want the reverse of that. We want to know what percent are below. That's going to be 98.7% below. And that's the percentile. Remember, we always identify these percentiles by what percent of the values are below it, not by what percent are above it. So the percentile estimate is really just based on one of those two variables, not the other. It's a question about one of the two quantitative variables, so we need to kind of isolate our thinking to be just in the up-down direction, ignoring the left to right for this particular case.